The last piece of the puzzle is how do we measure similarity? So how do we know or quantify how similar the output of two measures are? If we're looking at a measure that gives us parametric data and both sets of data have the same units, then we use something called intraclass correlation. This is common when you're doing test-retest reliability, for example. So you have two data sets from the exact same instrument. They're going to have the same units. You compare them with intraclass correlation. If you've got parametric data, but the data sets have different units, say you're evaluating one measure for concurrent validity by comparing it with another, you would use Pearson product moment correlation. If you have non-parametric data, if your instrument gives you categories that are either ordinal or nominal, so if you can put the categories in an order, you would use the Spearman correlation. If you can't put the categories into any kind of order, you would use Cohen's kappa. The one outlier to all of this is internal consistency. If you remember, internal consistency, you're evaluating whether all the items in some sort of test are measuring the same concept. If you've got a survey, so the functional independence measure, something or something similar that's got multiple questions, and you want to know whether all those questions are focused on the same thing, you're either going to use Cronbach's alpha or split half reliability. Split half reliability, you take your instrument, you break it in two, and then you compare the results of those two halves, and they should be similar for the same people. What Cronbach's alpha does is splits the questionnaire or instrument up into every combination of two halves. So the top half and the bottom half, the odd numbers and the even numbers, all those different combinations, and does the comparison over all of them. So if you're using a spreadsheet and doing a quick evaluation, that's split half reliability. If you're doing an in-depth evaluation of an instrument, you're using Cronbach's alpha. Now, once you've done these tests, what is similar enough? For our purposes, for reliability, we expect correlation to be greater than 0.9. If you'll remember, a correlation can go from -1 to +1. In most cases, we are looking for our two measures to be positively correlated. So when one goes up, the other goes up. And for reliability, we're measuring the exact same thing twice, so we expect extremely high correlation. So 0.9 or above is extremely high correlation. For Cohen's kappa, the equivalent is greater than 0.75. For internal consistency, if you use Cronbach's alpha, you're looking for a consistency greater than 0.9. For validity, where we're using two different instruments, we have lower expectations for agreement. So high validity is a correlation of greater than 0.6. For Cohen's kappa, we keep the same 0.75.